Functional interface, one of the most talked about concepts from Java 8. So, what is functional interface? A very basic definition is that it's an interface that contains one and only one abstract method. That means this single method must specify the intended purpose of the interface. And we can say that in this way, a functional interface typically represents a single action. For example, the runnable interface, which used to make a thread run, is a functional interface because it defines only one method called run, and run defines the action of runnable. To put it in another way, after all, what's the primary purpose of an interface? We define an interface to define some function in an abstract form. That is, we only define the what part, not the how. And the class which is going to implement it, the implementation of this function that we defined in our interface, we let that class to decide how to define that function or how to use that function or those set of functions. That's why by contract an interface looks similar to an abstract class. And whether we mark explicitly or not, all methods inside an interface are public and abstract except the default ones, a feature launched more recently. So earlier we used to group the common behavior with a natural goal under a single interface. And now to fine tune this approach, to limit this abstractness of an interface to a more specific behavior, the idea of functional interface is being introduced, like run for enable. So when you say that an interface is a functional interface, then the interface must contain only one abstract method through which we can recognize its functionality. That's why functional interface sometimes referred to as a SAM type, where SAM stands for single abstract method. Now the question is, how can we ensure that the interface contains only one method? So from Java 8, to ensure that and to make it to ensure that no other developer in your team break this contract, an annotation called functional interface has been introduced, and that annotation forces us to make the marked interface remain functional interface. How we do that? Let's see with the demo. To see how the functional interface work is actually very simple. Let's say I'll define an interface, some interface with certain method. Void function 1, function 2, and function 3. As long as it is just a normal interface, it is fine to have as many abstract methods as you want. But the moment you will mark this interface with the functional interface annotation, the compiler will show you the warning that this interface is invalid because it is not a functional interface, because you have more than one abstract methods inside your interface. So to correct this, we'll have to remove the other two. And this is possible from the Java 8 only because now we have this annotation. So that's how we identify that whether an interface is a functional interface or not. Now the question is, and you must be wondering that what's the use of such an interface other than defining a single abstract method? So functional interface use for the lambda expression, or we can say use as the target type of the lambda expressions. And lambda expressions combined with functional interface supports the functional programming in Java. How the two works together and what could be the possible scenarios where we need such kind of improvisations in our code base. We'll discuss all that in the next part.